actually is a thing worth talking about. So anyway, what I'm going to try to do is to quickly go through material that usually takes an hour to do in 20 minutes, okay? So it's going to be a little bit fun. It's going to be a little bit risky because we've got some demos that may or may not work. If it doesn't work, I'll tell you what you're supposed to have seen, but whatever. So you'll know that if it doesn't work, you'll know that it was real, right? Okay. All right, so the title was picked first. We just created a nice looking foil, and then we said, what do we put in the foil set? And then we took a bunch of pictures, put them in the foil, and I'm talking, okay? All right, so let's speed up here. Personalization of compute, what does it mean? Those of you, how many of you are software developers? Okay, wow, okay. How many under 35? Okay, very good. So you guys are the lucky lot because we programmed and wrote software in the boring days. Do you guys know what COBOL is? No, okay. Some of you know what Fortran is? Okay, all right, let's not go there. So we did all the boring stuff so that you guys all could be born 15, 20 years later and have all the fun, okay? And we watch you have the fun, and I don't even know how to play a game on my cell phone, okay? So that's the state of the world. So what's happening with personalization of compute is we've gone through 3 phases. I don't have the time to describe all of that stuff. But where we are today is that consumers drive technology, right? Even 15, 20 years back, computers and technology first came to enterprise, came to businesses. People did things in the office, and then they said, I want it at home, right? That's how it started. The thing that first started transitioning that is Wi-Fi. Wi-Fi was the first technology that did first go into enterprise, but the real scaling happened when people wanted it at home, right? Today what's happening is, particularly I think the seminal event was obviously iPhone, touch, and so on and so forth. All of you know that. So that seminal event caused people to completely flip over and wait for consumers to tell you what technology they want. So today technology first comes to home. People use it at home and in their regular lives, and then they say, oh, it'll be nice to have it at work, right? So I used to have a really boring smartphone for my work, and I had a really cool cell phone for my personal stuff, and then that flipped, right? Now I use the same phone for both. So that is the idea of personalization, okay? So in that, we think of personalization in 3 different categories or assumptions or however you want to think about it. The first aspect of that is what we call sensification. This is the profusion of sensors in our devices. There are devices now that have 20 or 30 sensors. The more regular cell phones probably have 10 sensors, 12 sensors, whatever. So this idea of adding sensors to compute is probably the biggest transition we are going through. So I'm not going to bore you about gyroscopes and accelerometers and magnetometers and GPS and all of that stuff. I'm going to talk about something very, very specific, which has to do with the most important sense, or at least one of the most important sense, which is the sense of sight. What happens when you add sight to compute? And that is going to be the one thing that I'm going to spend the next 17 minutes talking about. And once you have that sense of sight, which actually generates an incredible amount of data and has to be processed in a way that you can actually deliver some very good value to the user, there is an incredibly smart and connected environment that has to grow around you. I'm not going to have the time to talk about that. That's for a future conversation. Similar is this idea of what happens with technology where things have to become invisible. Over time, the idea that we are carrying a device will become less and less important. The fact that you're actually trying to do something with it will become more important. This actually crystallized in my mind when I was in a Uber taxi in Chennai, where the taxi driver really complained to me that every time when the car stops, taxi stops, he takes a customer to a destination, he's in a state of tension because he doesn't know when he pulls the device out whether the damn thing is going to connect, so that he can show them the number so they pay him, because a lot of people pay them by cash. And he's in this state of tension. So he tells me, without using big highfalutin words that we use about UX and all of this stuff, he says, can you just do something that tells me a number? Somebody says the number and the guy can pay me. So that's where we have to get to, is that technology and devices and software doesn't get in the way, right? And that is what we think this very early stage of sensification is going to do. So what happens if there is actually a 3D camera watching the driver, right? A lot of things can happen. So just a few examples that I'm going to talk about. So I'm going to talk about sensification of compute in a very specific sense, adding sight to compute. And it's a 10-year journey, guys. This is not going to happen tomorrow, okay? Just to get to a point where we could add 3D cameras, right? Which gets you that first ability to put the idea of the sense of sight into devices is just happening now. And it has taken 5 years to get to this point. Intel is one of the investors. We've invested for 5 years internally, hundreds of millions of dollars. We invest about $150 million a year just to get this one device ready so that it can start coming into your smartphones, into your tablets, into your PCs. I hope some of you still use PCs, but that's for another conversation. So into PCs, into your cars, all of that stuff, right? So it takes a long time for these things to happen, and the trigger, the point of transition that we are in right now is for the software industry to take over, right? It's very easy at some level, once you get the hardware right, once you get the functionality of the hardware in place, you get the latency down to the right levels, you get the right frame rates, you get the right resolution. When you do all of that stuff, hardware is kind of done. We move on, right? What we now need to do is to really take that into applications that people can use. A lot of different applications. We are not going to be able to get into each and every one of them. Many of them, you guys know, virtual reality and augmented reality are probably two of the biggest ones that we are, I think, going to go in a very big way. There are some very, very critical problems in these spaces that have been solved in the last 5 years that actually makes them real, right? It's not very fun to put on a HMD into your head, watch something really cool, and then take it off and throw up. It's not a great experience, right? So you have to fix those kinds of problems, and that's what technology has been doing, right? And what we are now doing is to be then able to add the sense of sight, the equivalent of something watching you while you're in that alternate environment, or something watching you when you are in that mixed reality environment of the real world with augmentation on top of that. So it's very simple. Virtual reality, you're cut away from the real world. Augmented reality, you're still in the real world, but there is some digital data on top. That's the only difference. But we are now taking that to the next step where you can actually be watched. And that makes a huge difference to the types of solutions that can be built. It goes across a number of different areas. Skill development, training, I think is going to be a massive area. Everything from life-saving things like surgery to more simpler things like digital books. We have this wonderful product where literally when a child is reading a book, a butterfly actually flies out of the book. And with haptics, some of you know what haptics, the child can actually feel the butterfly, as if the butterfly has landed on your hand. And these are not things that are just on video. These are real pieces of software that people have developed, and those are all starting to roll out now. Now, the question for the software industry is, do you guys, how far can you push your imagination? How far can you actually develop software that can actually take advantage of this? So there's one thing that we want to show you as an example. That's the one that says background extraction on top. And if you can roll the video really quick.
Everyone told me the same damn thing. You all told me to escape from here. I like to feel the fresh air on my skin, and I'd like to breathe, and I'd like to live like every day could be my life.
So it may not have been the easiest one to understand, but what was happening there is that 3D camera, the RealSense camera that was looking at that woman, was taking her image, subtracting out the fact that she was actually sitting in a bar or in a coffee shop somewhere, and actually very precisely have her 3D model available in real time so that she can actually replace the background. Now, it's kind of silly, it's a cheesy little video. It doesn't really mean much. But the applications of that becomes incredibly important. When you're doing training videos, a lot of times when you're watching, what's his name, Sal Khan on Khan Academy, you're just kind of hearing that voice, and it gets tiring after a while. If you actually had a live 3D image of him on the screen, superimposed on the content that you're actually learning, it is actually like as if you're in a classroom. Think of Twitch. How many of you know what Twitch is? Twitch. Okay, I'm actually a little surprised. I thought maybe more hands will go up. But essentially, this is a bunch of people who watch other people play games online. I had no idea this happens, okay? There are millions of people who sit in front of their computers and watch other people play games, okay? And apparently it's a massively growing trend. In that, they would like to see the emotion of the guy playing the game, right? And how are you going to do that? You can either watch the game or you can see somebody's face. with technology like this, you superimpose, right? So there are many, many different applications of background extraction. What this is doing is, with depth information, when you have a 3D camera, in addition to the RGB information, you have what? Depth. You have D. You have RGBD, you have depth information, so you can actually very precisely cancel out the background and then superimpose that image onto anything you want. So it's just one example, but lots of applications. And similarly, when you put eyes on things like drones and robots, magic starts to happen. So we're going to share a few things with you on that. I've got 10 minutes left, so I'm going to run out of this foil really quick. That way, sorry. Okay, why don't we roll this video and then I'll talk to it. How many of you think it's hard to do? Okay, at least somebody thinks it's hard to do. Okay, so it is very, very hard to do, okay? So what you, if you don't trust me, take your drone to the forest and let it fly, okay? And you'll find out how long it flies. So the only thing that the drone was given as information before it started was that little hand that pushed a button, right? I mean, some of you might have seen it. When the video started, somebody pushed a button, and that's it. It gave it a GPS coordinate where to reach. That was the destination was given, and everything else was done by 6 3D sensors that were mounted on top of that drone, from collision detection to acceleration to turning and navigation, the whole 9 yards. It's extremely complex. It's very real-time computation, and you have to do it precisely. You miss it by a few nanoseconds. You know what, or maybe milliseconds. Nanosecond is maybe an exaggeration, but you can't miss it, right? You're going to destroy the drone. So it took probably a bunch of smart engineers about 6 weeks to develop that piece of code just to navigate that forest, right? So it's pretty complex to do, but that is directionally where a lot of things are going, that you have to have, with the level of compute you have on these devices and the opportunity now to have a 3D sensor or a 3D camera in these devices, you can actually do a lot of these things that were previously more difficult to do. The next example, actually what we will do is, I'm going to have Parag quickly do a demo, and this is the one if it fails. You guys know it was real, and then I'll talk about it. Go ahead.
Just give it a second to initialize. So what we have here is a device in my hand which has the RealSense camera embedded on the phone, and he'll be talking through that and what the camera is really. But what I have here is a device which detects planes, which itself is pretty awesome. So when I hold the device out, it knows where the ground is, the plane is, and when I roll it up, it knows where the sky is, which kind of opens up a lot of things which I can do with it. Now, let me show the demo. In this demo, we are going to construct a small structure. So as you would know, to construct a structure, I'm going to need some foundation. So I'm going to lay out some foundation in 3D. Let's lay out some blocks here. All right, so that's our foundation. Now what's cool is that if I turn around and let's say I'm looking in this direction, and when I return back to the foundation, it remembers where it is. That means it's real, it's 3D, and it really is there. Now let's go and construct something. So I'm going to select brick over here, and I'm going to try and construct some structure. Or I need to get a little closer to my foundation and try and construct a structure over here. Okay, let's give it one more layer. All right, and I'm going to try and connect my structure. Okay, so now I have a 3D structure in space. What's cool is that when I move the camera, I can literally, I'm sorry I'm limited by this wire here, but I can literally go inside the structure, see from the top and so on. So isn't that cool? Thank you.
Okay, all right, good. Okay, so you can imagine how many different types of applications this thing has, from design to architecture to tourism applications to training applications. Our imagination is the limiter here. So there's a lot of things that will happen as a result of this camera that literally 3 years back looked like a very thick candy bar, right? That was the size of the camera. Now it's reduced down to a form factor that can be fit into a general smartphone. I mean, most people are carrying 6-inch or 5.5-inch smartphones. That form factor, you can get the 3D camera in. You can get it in your tablets and PCs and all of that stuff. Go buy some PCs, guys. Okay, and you know, we are really limited by the imagination of what the software industry can do in terms of building applications on top of this. You're going to see a fairly rapid expansion of this in the marketplace next year. There'll be a decent single-digit millions of units that'll already be in the marketplace next year, and then 2017 is massive ramp. So there'll be 3D sensors everywhere, and they'll go into all kinds of different device form factors. Okay, very quickly, I've got 4 minutes left. This is a robot that's deployed in a loft hotel in Cupertino. It's expanding out into about 10 hotels as we speak. I think by the end of November, it's 10 or 15 hotels. What it does is really replaces room service, right? So think of this as a device like this sitting on a charger by the guy at the front desk. You want a newspaper, you call him, he drops a newspaper, enters your room number, and from that point on, this thing is completely, fully autonomous. It navigates its own way through, it walks up to the, or rolls up, or whatever you call it, up to the lift, and knows exactly how to get to your room. Gives you the stuff. There is interaction between the customer and the robot, and then it quietly comes back and sits on the charging station so that you can send it off on its next job, right? So again, possible because there is 3D sensor built on it to avoid collision. A child runs across. In real time, it has to make sure that there's no accident there, and so on and so forth. There's about 10 other things I can talk about this, but unfortunately, we probably don't have time to do that. Okay, last example, I think this to me is going to be very, very interesting how this plays out. This is a magic mirror or various other terms that are being used, but essentially what it is a mirror, it's a display, digital display with a 3D camera on top. And the shopper comes into a store, tries on a dress or a jacket, doesn't like the color, and at the push of a button can try on different colors, and the person's still wearing the physical garment that the person's wearing, but digitally it is precisely texturally accurate, photorealistically changed onto the magic mirror. Again, these are not pipe dreams. This is getting rolled out in the holiday season. 3 of the major chains are going to have it. I'm not sure if the names are public yet, so I'm not going to use it, but they are very large clothing chains, all in the US, but I think it'll all come to the other markets very, very quickly. And this kind of thing, because 3D cameras, they'll then roll into your home, it creates a massive opportunity for all the commerce stuff that people do from home. So if you go buy a desktop, it'll actually give you a better experience. And then you have the 3D camera in front of you. You try something online. You want to see it on your own self. The magic mirror actually lets you, change whatever clothing you want. This applies to all kinds of things we buy. Everything is 3-dimensional, so it gives you the ability to actually see the physical product virtually like how it is going to be in real life. 1:29 left. Okay. All right, here we are. I think I'm done almost. Why is it not working? Okay, all right, so how does this roll out for the software industry? Most critical, Intel built the RealSense camera. I talked to the millions that are going to be available. It is going to be available as an SDK in virtually any operating environment that you're going to be in. If you're in any of the standard Android, Windows, Linux, whatever environment, or you're in a gaming environment like Twitch, you're building a robot in ROS, it's going to be integrated into everything. So it's just an API call. You can build your software based around this. There's really no difference for you as a software developer what platform you're developing it for. What you're going to do with it, it may be different, but I think in terms of actually building the software, it's going to be very easy. All right? Okay, this is sort of an India-specific foil. Talks about all the different areas in which this can potentially go in. I think I touched upon it: skill development, urban renewal. There are applications in terms of waste management and all kinds of things you can do as soon as you have a sense of sight. The unfortunate problem is that we create literally billions and billions of images a day. They are not real, right? They're all 2-dimensional. They're all flat. Every image that you send to each other, or you put it on WhatsApp, or you email it to somebody, it's all flat. It's not real image. What is actually happening is when you get a 3D image, you're finally getting to see the real world. That is the big transformation that's happening as soon as you put sight onto compute. Okay, and I'm done.